A logarithmic function is an inverse of an exponential function. So remember, when you have an exponential function, if you're trying to find the inverse of a function, what you do is you replace the x with y and y with x, and then you solve for y. So if you were to solve for y, what would you do? So the new definition is we would actually write this as a logarithm. So the equation is, if y equals b to the x, then log base b of y equals x. So b to the x equals y. You cross over. So these two are the same thing. Log base b of y equals x, and y equals b to the x. So I can write these as logs. So this would be y so log base 3 of y equals x. So the inverse of that would be y equals log base 3 of x. So if I wrote this one as a logarithm, it would be log base 6 of y equals x. And if I write the inverse of it, it would be y equals log base 6 of x. This one, is going to be y equals 4 to the x as the inverse. And this one's going to be y equals 8 to the x as the inverse. And this one's going to be y equals log base 10 of x. So you'll notice that if I graph these, so if I plug in -2, -1, 0, 1, 2, 3 for x, I'm going to get 1/9, 1/3, 1, 3, 3 squared is 9, 27. And if I do this, if I write it as an exponent, so this is going to be 3 to the y equals x. So what you can do is you can plug numbers in for y. So I'm going to plug in numbers for y. I'm going to plug in -2, -1, 0, 1, 2, 3, and see what I get for x. Because these two are the same right here. I wrote this logarithm as an exponential function, and so for me it's easier to plug in y and see what x is. So you'll notice I get 1/9, 1/3, 1, 3, 9, and 27. So what happens is this is showing right here that these two are inverses. Y equals log base 3 of x and y equals 3 to the x are inverse functions because their domain and range have been switched around. So if I drew a sketch of this, rough sketch, the exponential function is going to look like this. And then I'm going to draw my line y equals x. And the logarithmic function is going to look like this. So the log function has a vertical asymptote at x equals 0. And the exponential function has the horizontal asymptote at y equals 0. So we notice that they are inverses. Now using exponents, you can also evaluate logs. So I'm going to write these as an exponent. So we're going to use log base a of b equals x is the same thing as a to the x equals b. So you should be able to write these logarithms by converting into exponents. So this is going to be 2 to the x equals 32. So this is 6. The next one is going to be 6 to the x power equals 36. Well, that has to be 2 because 6 squared is 36. Next one is 5 to some power x equals 625. So that's 4. The next one is 3 to some power of equals 27. So that's 3. 3 cubed is 3, so the answer is 3. Next one is 4 to the some power equals 64. So this has to be 3. 8 to some power is 1 over 64. So I'm going to write that. 8 to some power equals 1 over 64. So this has to be a negative exponent because 64 is on the bottom and 1's on the top. So it's going to be negative 2. And then 81 to some power equals 9. So 81 to the 0, no. 81 to the negative 1, positive 1, no. So it's actually the square root of 81 is equal to 9, so this has to be 1/2. And then 13 to some power equals 1. That has to be 0. Any number to the 0 power is 1. So most common logs are base 10 logs. So if there is not, see, there's not a little base at the bottom. So normally we have logs with a little base right here. So the little base right here would be a. So log base a of b equals x. So if there is not this number a right here, it's assumed that it's going to be base 10. So actually, if you want to write this as log base 10 of 1,000, so it's going to be 10 to some power equals 1,000, so that's power 3. This one's going to be 10 to some power equals 10 to the 8th, so that power has to be 8. And this one is going to be 10 to some power equals 100th. So I'll write that out. 10 to some power equals 1 over 100. So that has to be a negative exponent. That's going to be negative 2 because 10 squared is 100, and 100's on the bottom of the fraction. And then this one is 10 to some power equals 10 to the negative 5th. So that power has to be negative 5. pH is a log function. So pH is the acidity of something. So the pH of an apple is about 3.3 and that of a banana is 5.2. The pH of any substance equals opposite log H plus, where H plus is the concentration of hydrogen ions. Find the concentration of hydrogen ions in each fruit, which is more acidic. So I'm going to use this formula, pH equals, so apple is 3.3 equals opposite log of H plus. So this H plus is just a variable. So if you want it, if it makes you feel better, do 3.3 equals opposite log x. So we're going to divide both sides by negative 1. So negative 3.3 equals log x. So remember, if this is just log x and there's no base, there's a little 10 right here. So it's going to be 10 to the negative 3.3 equals x. So on my calculator I got 5.01187 e negative 4. So remember that e negative 4 is just the scientific notation. So I'm going to bring my decimal back 1, 2, 3, 4. So the apple is 0.0005 as far as what the H plus is, the concentration of hydrogen ions, excuse me. So then now I'm going to do the same thing for the banana. So the banana is 5.2 equals opposite log of x, where x is the pH, is the concentration of hydrogen ions. And so this is going to be negative 5.2 equals log x, but this is just going to be base 10. So it's 10 to the negative 5.2. So I do 10 to the negative 5.2. and I get a much smaller decimal. So it's 0.000000631.